we left off last class. Last class, I told you what distributions are, which essentially are if I draw a histogram and kind of like connect the dots of the bars to create a little smooth line that isn't really as useful as a histogram, as it doesn't tell us exactly how much each thing is, but it kind of gives like a rough estimate of what's going on. All right. I think Carolyn has the notes. So, all right. So we have different shapes of histograms or distributions that we've talked about. And we even learned this crazy rule called the 68, 95, 99.7 rules. And this applied to normal distributions. Now, normal distributions are, is that picture that looks like the bell curve, right? So whenever we have a graph that looks like a bell, this rule applies. And we were able to figure out, okay, if we were within 1 standard deviation or 2 standard deviations or 3 standard deviations of the mean, how much of the data kind of lies underneath that curve, or what percentage of the population is in there. Okay, so that was really useful for us, but unfortunately, the 68, 95, 99.7 rule doesn't apply when we're not looking within 1, 2, or 3 standard deviations away from the mean. Sometimes we're 0.5 of standard deviations above the mean. Sometimes we're, I don't know, 1.7 standard deviations below the mean. And that's where this thing called the z-score comes along, okay? Before I go over this formula, let's just do a little review. We had a couple symbols, right? We had this symbol here, and what did that stand for? The mean, good. And we had this symbol here, and that stood for the standard deviation, good. Okay. And if we have any distribution, let's just pick the normal one because it looks like a bell curve. Okay. The mean is always going to be in the middle, right? The mean, median, and mode of normal distributions are smack in the middle. Okay. And if I go to the right of the mean, I'm going above the mean. And if I go to the left, I'm going below the mean, right? Okay. So let's say I went the mean plus, I don't know, 2.5 standard deviations above the mean. What would be the z-score that corresponds to? 2.5, right? Okay. What if I took the mean and subtracted off, I don't know, 1.7 standard deviations? What would that z-score be? Yeah, negative 1.7. And what about the mean itself? What is that z-score? How many standard deviations away from the mean am I at the mean? 0, right? So at the mean, I am no standard deviations away from the mean, which is what the z-score represents. Okay. Now we have this formula that I told you to memorize, and this tells us what the z-score is. So if I have an x value and I wanted to find what z-score it lies, so how many standard deviations away, above or below from the mean am I? You're going to take the x value, subtract off the mean, and divide the standard deviation. That gives you the z-score. Okay, let's do a little example here. Okay, in this example, we have a teacher, and the teacher gave 3 versions of a test to her students. Now that's some dedication. I don't think I would ever write 3 versions of an exam, but good for that teacher. All the versions are normally distributed, and let's see, test version 1 had a mean of 66 and a standard deviation of 4. Okay. Now, as I read this question, when I'm given a big word question, I like to organize everything in charts, just because if I go back to the question, if I'm trying to do the question, I go back to the question, I'm trying to read what's going on, my vision is going to get blurry. I'm not going to know what things are. Okay. So test 1 has a mean of 66. So let me just write that down here, and a standard deviation of 4. Once I organize it in a table, I don't have to go back to the question and try to read all the words up here, and it gets all nasty, right? Test version 2 has a mean of 66 and a standard deviation of 2. And test version 3 had a mean of 72 and a standard deviation of 6. Okay, very good. Now I never have to go back to my question. All I have is my chart. Okay. We have Lewis, and he received a 76 on test version 3. Okay, so we're focusing on the right sort of data, right? I want to know his z-score. Okay, so when I look at this, I'm gonna go and write the equation down. Z equals X minus mean over standard deviation. Okay. Let's start with what we know, okay? I know that the mean is 72, because under test version 3, I have 72. I know the standard deviation is 6. What does 76 represent? X value, right? We're asking what the z-score is. Lewis received a 76. That's an actual data point, okay? So X is 76. Okay. So plugging in, we got 76 minus 72 over 6. When you do this, I recommend doing the subtraction first and writing down the number. So 6 minus 2 is 4 over 6. Once you write that down, you can go in your calculator and divide to get 0.667. Okay. Let's talk about what that actually means. Okay, so we got a z-score to be 0.667. Okay. The z-score represents standard deviations away from the mean, okay? Now my z-score is positive. So what does that mean? Am I above the mean or below the mean? Above the mean, right? Above, and I'm gonna use the symbol above mu, okay? And if I wanted to write this in words, I know that Lewis scored 0.667 standard deviations, right? Above the mean. Okay. So in terms of standard deviation, that's how much. Any questions on number 1? All right. Why don't you try number 2? I think we're good on 2. Let's give that one a try and we'll come back. Really good answers. Kamara did a great job of finding the z-score. Do you kind of want to take us through your steps here? Mhm. Mhm. Great job. Perfect work there. I want to talk about how we interpret our results here. Okay. Now, in part 1, it was really easy to interpret it because we had a positive z-score. Here, when we're going to interpret it, I know that z-score talks about how many standard deviations we are above or below the mean. Since it's negative, do you think we're above or below? Below, okay. So we know, or I'm not gonna write we know, that Jamie scored some sort of standard deviations below the mean, right? And it's probably 0.333 standard deviations below the mean, okay? Now, it is negative though. Should I put that he scored negative standard deviations below the mean? No, right? Because but when I say below, it's accounting for the negative, right? So I don't need to repeat the negative because that would counteract the fact that I said below, right? So when we're talking about how many standard deviations we are above or below, we're talking about a distance, and distance is only going to be positive. We can't talk about negative above or below. Okay. Any questions on number 2? All right. Let's go to number 3. This one's a little bit different, right? So this one's giving us the z-score, and we want to know what the test score is. So this one is actually asking us for the x value instead of the z-score, okay? So let's write out the equation here. We have z equals x minus the mean over the standard deviation, okay? We're looking at test version 1, so if I take a peek back at my version 1, I know that the mean is 66 and the standard deviation is 4, so I can fill that in. Gosh, I know that we have x minus 66 over 4. That's right. Okay. And it's giving us the z-score, so I guess the z has to be here. Negative 1.5 equals x minus 66 over 4. Everyone good with how I, oh my gosh, everyone good with how I wrote that out? Good. Okay. Now we have to isolate x, right? What should I do first to isolate x? Good. We have to multiply first. I know there's a -66, but the biggest thing over here is the division, right? And to undo division, we need to multiply. So I can multiply by 4 on both sides. On the left-hand side, I get -6, I think. And on the right-hand side, the 4's cancel out and I have x minus 66. Okay. Finally, to get x by itself, what do I need to do? Add 66 to both sides. And I should get 60 on one side and x on the other. That's my answer. Any questions on number 3? All right, let me give you a few minutes to work on number 4, very similar to what I've done. And then we can talk about it.
Good question. Do you have to write like it in like that sentence for these problems?
I would say if I ask you to interpret the z-score, so if I ask you like, what does this mean in terms of standard deviation and mean, I would expect you to write something like this. But on questions like these, it doesn't ask you because it's just asking for the x value. So you don't need to write the sentence for like number 3. That's a good question though. Let's come back up front here. Ashley did a great job of writing up her answer here. Her work looks really great. Do you kind of want to take us through your steps?
So I took the formula and then I figured out what each, I guess, value would be, and then found that you would have to find x. So then I did ×2 on each side, and then that star on that side got 4, and then x minus 66, add that to the other side.
Great job. Any questions on number 4? All right. So I didn't really know what else to do today. So I think what we'll do is we'll do the quiz review.